All right, activity 4.2, using random numbers to simulate compound probability. Overall, the percent of people in the US having each blood group is given in the table. The percents have been rounded to the nearest whole number percent. Suppose the Red Cross is having a blood drive at the community center. Number 1. What is the probability that the next person who enters the community center to donate blood has group A blood? Well, this is pretty simple, and it's just going to be 42%. Okay. And then what is the number 2? What is the probability that the next person who enters the community center to donate blood has group A or group O blood? The or is telling me that I need to take the 42% and add the 44% for type O. So A, O. And so that total should be 86%. And the key there is because it says or. All right, so determine the probability that out of the next 5 people to donate blood, at least one person has group AB blood. Okay? Describe different strategies you could use to simulate the blood groups of people who give blood. You can make a spinner, as we've talked about. Coins wouldn't really work because there were 4 different things with 4 different percentages. You could use a random number table. You could probably put like slips of paper into a bag. So like the percentage for each of them, like that's how many slips of paper, like 100 slips of paper into a bag. And then like, was it 42 for type A, 10 for type B, 44 for type O, and then 4 for AB. All right. And so for part B, they say, because of the values of the percents, use a random number table for this simulation. So they're telling us what to use. How could you assign numbers to people to account for the different blood groups? All right, so I could do 0 to 41 would be type A. Because if I look on here, it would be 42%, and 0 counts as the first one. Then you could do 42 to 51, and that could be type B because there's 10% in type B. And then next could be 52 to 95, and that'd be type O. And then finally, I could have 96 through 99 be that type AB. Okay? And that's what we're looking at here. 5 people have at least one person that has type AB blood. Okay? Describe one trial of the simulation. Well, in one trial, I would choose 5 2-digit numbers. And then see how many would be in AB. Okay. All right. D says conduct 20 trials of the simulation and record the results in the table. Okay. And so I could start anywhere. I could start anywhere on the line. I could start anywhere with this. But for this one, and you could do this yourself and it would be different. I'm going to kind of just put them together like this. 1, 2, 3, 4, 5, 6, 8, 9, 10. So I take those first 2 and those are the first 2. And so if I'm looking at this again, I'm looking for how many are AB, so 96 to 99. So 65, 28, 59, 71, 98. So there was 1. Okay. Maybe I'll go back and forth with 2 different colors here. and it's 5 people with 2 numbers each, so this is the next set. So 12, 13, 85, 30, and 10 has 0 people with AB donors. Okay. Then 94, 60, 15, 11, 58, 38 has 0 people with AB donors. Okay. 16, 80, 56, 14, 4 has 0 people with AB donors. 5, 43, 51, 61, 70, 20 has 0 people with AB donors. Okay. Going down to line 2 now. And like I said, I could randomly choose this however I would want, actually. I want to keep that in mind. 96 to 99 is what I'm looking for. 17, 26, 45, 73, 27, 0 that are AB donors. 38, 22, 42, 93, 0, 1, 0 are AB donors. 18, 16, 43, 81, 9, 0 are AB donors. 34, 97, 65, 56, 92, 1 is an AB donor. 98, 56, 62, 95, 50, 1 is an AB donor. Let's see here, line 3 now. 95, 63, 99, 97, 54, 2 are AB donors. 31, 19, 99, 25, 58, 1 is an AB donor. Popular. 68, 36, 80, 49, 85, 0 are AB donors. 51, 9, 23, 77, 80, 0 are AB donors. 40, 26, 11, 44, 79, 0 are AB donors. Line 4. 61, 55, 57, 64, 4, 0 are AB donors. 86, 21, 41, 18, 8, 0 are AB donors. 12, 84, 5, 51, 47, 0 are AB donors. 97, 43, 86, 2, 22, 1 is an AB donor. And then last, 12, 64, 56, 20, and 90, 0 are AB donors. Okay, so I used my random number table to kind of conduct 20 trials, and I recorded the results in the table. So I can write done in for this one. Out of the 20 trials, how many had at least one number that represented an AB blood donor? 1, 2, 3, 4, 5, 6. 6 out of the 20 trials had at least one AB blood donor, which is going to be the same as 3 out of 10, which is going to be the same as 30% or 0.3. Okay. According to your simulation, what is the probability that out of the next 5 people to donate blood, at least one of them has group AB blood? So in our experiment, it was 30% or 3 out of 10 or 6 out of 20 or 0.3. Okay. And then I actually know that the theoretical probability TP is about 18.5%. So in our experiment, it was a little higher than what it is theoretically, and that's okay. But we're just showing you how to run the experiment with a simulation. Notice that we didn't find 5 people and then test their blood. All right, simulation is not doing the exact same thing. All right. How many people would be expected to donate blood before a person in group B blood would donate blood? All right, so group B blood, according to our thing, was the random number table 42 to 51. And so choose random 2 numbers until you find one that would represent group B. Okay. B, conduct 20 trials of the simulation and record your results in the table. All right, so my sister's dog is great. My sister's dog is wonderful. Yes, I know. You're mad. I'm going to pause this 1 second. All right, sorry. Conduct 20 trials of the simulation and record your results in the table. So I'm looking for 42 to 51, and I'm going to kind of start where I left off, okay? And so we'll just see how many it takes to get to a 42 to 51. 78, 1, 13, 2, 79, 3, 87, 4, 68, 5, 4, 6, 68, 7, 98, 8, 71, 9, 30, 10, 79, 11, 22, 12, 50. And so it was on the 13th one that we got someone that would be falling into the group B category. Okay. All right. 1, 2, 3, 4, 5, 6. 6 until we find someone that falls into the group B category. 1, 2, 3. 3 until we find someone that falls into the group B category. 37, 49, 2. 1, 2, 3, 9, 92, 15, 84, 98, 72, 87, 59, 19, 10, 71, 47 is the next one. Let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, the 12th. Okay. Trying to make sure we can kind of see these as I'm doing them so you can kind of continue to see what I'm doing to use this random number table so you're understanding. So let's see if I can adjust this. I think I have. And continuing on, 33, 1, 2, 3, 4, 5, 6, 7, 8, 9. On the 9th one, it worked. Okay. Then we have 1, 2, 3, 4, 5, 6, 7. Then we're going to go and get 1, 2, 3, 4, 5. Almost halfway there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, holy cow, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Till we got to a group B. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Three more left, right? So we have 1, 2, 3. 1, 2, 3, 4, 5. Last one. 1, 2, 3, 4. Okay. So now I've got those all in there. Use my random number table, folded it up, conduct 20 trials of the simulation, record your results in the table. Done. Calculate the average for your 20 trials. Okay, so for that one, I need to add these up and divide by however many there are. So I'll do so. 13 plus 6 plus 3 plus 2 plus 3 plus 12 plus 9 plus 7 plus 5 plus 36 plus 9 plus 13 plus 9 plus 4 plus 2 plus 10 plus 11 plus 3 plus 5 plus 4. That's 166 total. Divide that by 20 trials. And so my average was 8.3. Okay. So it took 8.3 people until I got someone that would fall into the group B blood group. So how many people would be expected to donate blood before a person with group B blood enters? It'd be about 8 or 9 people. Okay. And then just to let you know, theoretical probability for this one is about 10 people. Okay. And so for this one, our experimental probability with our simulation was closer. All right. Or it was closer to the theoretical probability. Okay. So we're practicing using simulations to be able to find the experimental probability of compound events. All right. And so notice how when we do a simulation, it is not the same as what we do, is not the same as actually doing the experiment. Okay. We do something that would be like it. This was the end of lesson 4.2.